Children, welcome to Math Park. Today we are going to solve exercise 12B of topic midpoint theorem from the book Concise Selina, class 9 ICSE. So after going through this video, if you like it, please share with your friends. And if you are new to the channel, please subscribe. We start with question number 2 because first question is an MCQ. Here, this exercise is based on equal intercept theorem and midpoint theorem both. So let us understand what do you mean by equal intercept theorem. So when three or more lines are parallel to one another, we have line L is parallel to M is parallel to N, and then CE, DE, and AC are three transversals. So if the intercept, that is the part between two parallel lines made by one transversal equal, that means you have CD is equal to DE. Then the intercepts made by the other transversals are also equal. That is, you have CB is equal to AB, and also you have GF is equal to EF. GF is equal to EF. This is what is called equal intercept theorem, which we are going to use while solving this exercise. Start with the question. Use the following figure to find BC if AB is equal to 7.2 centimeter. So we start with the first one. You are given the three lines parallel and you are given CD is equal to DE. So if the intercepts made by the one transversal are equal, the intercepts made by the other are equal. So by equal intercept theorem, as CD is equal to DE, you have AB is equal to BC and EF is equal to GF. So you have AB is equal to BC and you have EF is equal to GF. Now you are asked to find BC. So if AB is equal to BC and BC is given, AB is given as 7.2, so then BC is also going to be 7.2 centimeter by equal intercept theorem. So the first one, you get BC is equal to AB, which is 7.2 centimeter. Second, find GE. Now GE is equal to GF plus EF. This GF plus EF. Now, since GF and EF are equal, we can write this as 2EF. So we get G is equal to 2EF and EF is given to you or F is given to you as 4. So G is equal to 2 times 4, which is 8 centimeter. Third one, finding AE. Now AE is equal to 2BD by midpoint theorem. So if you consider triangle, ACE. So where B is the midpoint of AC and D is the midpoint of D is the midpoint of CE, then half of the third, that is BD, is equal to half AE, or you can say that AE is equal to 2BD. So that is how you get A is equal to 2BD. Now if BD is given to you, which is 4.1, that is how you get A is equal to 2 times 4.1, which is 8.2 centimeter. The last part, DF is equal to half CG. Again, using the midpoint theorem for triangle CGE or triangle CGE, D and F are the midpoints. Therefore, you get DF is parallel, already given parallel. So, you get DF is equal to half CG. CG is given as 11. So, this is how you get DF is equal to half of 11, which is 5.5 centimeters. Moving to question number 3. In the given figure, you have 2AD is equal to AB. P is the midpoint of AB and P is the midpoint of AB. So these two are already equal. And Q is the midpoint of DR. Q is the midpoint of DR. So you have these two parts are also equal. And PR is parallel to BS. You have to prove that AQ parallel BS. Now, since you have 2AD is equal to AB, you get AD is equal to AP is equal to PB. Okay, 2AD is equal to AB and P is the midpoint. Therefore, you get AD is equal to AP is equal to PB. These three parts are equal. You have to prove AQ parallel RS. So, in triangle DPR, A and Q are the midpoints of DP and DR respectively. So, therefore, by midpoint theorem, you have AQ is parallel to PR. Now, AQ is parallel to PR, but we have AQ is parallel to PR, but we are given PR is parallel to BS. So, lines parallel to the same line are parallel to each other. So, therefore, you get AQ is parallel to BS because PR is parallel to BS. So, lines parallel to the same line are parallel to one another. We did the first one. Second case, you have DS is equal to 3RS. Now, you have DS is equal to 3RS. Now, by equal intercept theorem, you have QR is equal to RS. Okay, QR is equal to RS because AP is equal to PQ. Therefore, QR is equal to RS. These three lines are parallel to one another. and AP is equal to PB. That's the reason these are the intercepts made by DB are equal. Therefore, intercepts made by DS are also equal. Therefore, you get QR is equal to RS. And you have DQ is equal to QR because Q is the midpoint. QR is equal to RS and DQ is equal to QR. So, therefore, from this equation 1 and 2, you get DQ is equal to QR is equal to RS. These three are equal. And this is how you get DS is equal to 3RS because DS is nothing but DQ plus QR plus RS. And instead of all of these, we can just write RS. That is how you get DS is equal to 3RS. Question number 4. The side AC of triangle ABC is produced to point E. And you have CE is equal to half of AC. CE is equal to half of AC. D is the midpoint of BC. D is the midpoint of BC. So BD is equal to DC. And ED produced meets AB at point F. Lines through D and C are drawn parallel to AB. That means DP is parallel to AB and CR is parallel to AB. So this of AB and DP and CR are parallel to one another. You have to prove that 3DF is equal to EF and 4CR is equal to AB. Let's start. So in triangle ABC, you have D is the midpoint of BC and DP is parallel to AB. Therefore, by converse of midpoint theorem, you get P is the midpoint of AC. So this AP is equal to PC you get. And PD is equal to half AB. By midpoint theorem, you get PD is equal to half AB. Let this be equation number 1. Then you have CE is half AC given. Now, instead of AC, we can write AP plus PC. So, AC is nothing but AP plus PC. Now, since P is the midpoint, AP plus PC, you can write 2PC. So, you get PC plus PC. This is how you get 2PC. Now, this 2 and 2 got cancelled. We get CE is equal to PC. We got CE is equal to PC. So, these three parts are now equal. AP, PC and CE are now equal. So, that is how you get AP is equal to PC is equal to CE. Now, let us draw a line parallel through E, which is parallel to, let us say line L is parallel to CR, is parallel to PD, is parallel to AB. So, therefore, let us write this as line L, which is parallel to AF, is parallel to PD, is parallel to CR. So, by equal intercept theorem, so since we have AP by equal intercept theorem, we get DF. We get DF is equal to DR is equal to RE. Okay. So, this by equal, since the intercepts made by transversal AE are equal, the intercepts made by transversal EF are also equal. That's what is equal intercept theorem. Now, DF is equal to 1 by 3 EF because DF is all the three parts are equal. So, this is 1/3 of the entire line segment. So, you get DF is equal to 1/3 EF, or you can say that 3DF is equal to EF. This is what was the first part that we have done. 3DF is equal to EF. Now, moving to the second part to prove 4CR is equal to AB. Now, let us look at the triangles wherein the lines are parallel. We use the midpoint theorem for that. So, we have PED. We are looking for this triangle PED. You have CR is parallel to PD and CR is equal to half PD. But PD is equal to half AB given to us. PD is equal to half AB. So, let us substitute this PD is equal to half AB from 1. So, instead of PD, we put PD is equal to half AB. Half of is 1 by 4. So, this is how you get CR is equal to 1 by 4 AB. This 4 moves here. 4 CR is equal to AB. Done with question number 4. Question number 5. In triangle ABC, the medians BP and CQ are produced. The medians BP and CQ are produced to M and N. So, median BP and CQ are produced to M and N respectively such that BP is equal to PM, BP is equal to PM and CQ is equal to QN. You have to prove that MAN are collinear. To prove MAN collinear, we need to prove this as a straight angle. MAN as a straight angle and A is the midpoint of MN. So, we need to prove AN is equal to AM. Let's start. So we have, let us prove this triangle is congruent in triangle BPC and triangle MPA. We have angle BPC is equal to angle APM, vertically opposite angles. These are vertically opposite angles. Then you have BP is equal to PM is given to you. BP is equal to PM is given to you. These two parts, BP and PM, are equal, which is given to you. And also you have PC is equal to, this PC is equal to PA. PC is equal to PA because BP is a median. So therefore, you get the triangles are congruent by SAS, side angle side. You get these two triangles congruent, S by SAS. So since the triangles are congruent, we have angle, you get angle PCB is equal to angle PAM, corresponding angles of a congruent triangles. And you have BC is equal to AM. So this BC is equal to AM by CPCT. Now, since we proved these two triangles congruent, similarly, we will be able to prove that these two triangles congruent, the one which I have masked chart. So, if we prove these triangles congruent, then we will be getting this angle QBC will be equal to, angle QBC will be equal to angle NAQ. And also, you will get NA is equal to BC by CPCT. Got it? So we will be able to prove triangles CQB and NQA will also be congruent by SS as we did in the previous case. And therefore, you get angle QBC is equal to angle QAN. Let that be equation number 3. And you have BC is equal to an equation number 4. Now, let us say the angle sum property of triangle ABC. So in triangle ABC, you have angle ABC, which is this angle, plus angle ACB plus angle BAC is equal to 180 degree. From equation 1 and 3, let us replace these angles. So ABC is nothing but QBC and ACB is nothing but PCB. Replace this angle, so we get from equation 1 and 3, we get QAN plus PAM plus BAC, that is QAN plus PAM plus ABC. These all three angles add up to 180 degree. And since this is a straight angle, we can say that MANR collinear. These are the straight angles, therefore MANR collinear. Now look at this equation 2. You have BC is equal to AM by CPCT and BC is also equal to AN. So from this equation 3 and 2 and 4, we get AM is equal to AN. And thus we can say that A is the midpoint of MN. Got it? ABC, you have angle B is an obtuse angle and D and E are the midpoints of sides AB and BC. So B is the midpoint of AB and E is the midpoint of BC. So you have EE is equal to BC and also you have DB is equal to AB. The midpoints. And F is the point on AC such that F is the point on AC such that EF is parallel to AB. EF is parallel to AB. So line drawn to the midpoint of one side parallel to another bisects the third. That is how you will get F as the midpoint of AC. So in triangle, in this we have EF is parallel to AB and E is the midpoint of BC. Therefore, by converse of midpoint theorem, you get F is the midpoint of AC. You get this two part equal. Is the midpoint of AC. Now, you have EF is equal to BD. Now, why EF is equal to BD? So, you have EF is equal to half of AB. By midpoint theorem, you will get EF is equal to half of AB and half of AB is nothing but BD because D is the midpoint of AB. So, you got EF is equal to half AD. Now, BF is parallel to BC by midpoint theorem because B is the midpoint of AB and F is the midpoint of BC. Therefore, BF is parallel to BC. And since BF is parallel to BC, DF is also equal to half of BC. So, this is how you get DF is equal to BE. Okay, so DF is equal to BE. Now, since both the pairs of opposite sides are parallel and equal, you get BEFT is a parallelogram. Both the pairs of opposite sides are parallel and equal. Therefore, you get BEFT is a parallelogram. In a parallelogram ABCD, E and F are the midpoints of the side AB and DC respectively. The line segments AF and AF and BF. The line segments AF and BF meet the line segments ED and EC at point G and H. You have to prove that triangle HEB, this triangle HEB and triangle FHC are congruent. So in these triangles HEB and HCF, we have DE is equal to BE is equal to FC given. Why given? Because these are the opposite sides of parallelogram. AB and DC are the opposite sides of parallelogram. And F is the midpoint. So that is how. And E is the midpoint AB. So their halves are equal. So therefore you get BE is equal to FC. And then you have angle EHB is equal to angle FHC, vertically opposite angles. And you have angle HBE. Angle HBE is equal to angle HFC. These are the alternate angles. Since you have AB parallel to DC and BF is a transversal. So therefore you get the triangles congruent by AF. You got the triangles congruent by AF. Therefore you have EH. Look at the corresponding parts. EH is equal to CH and you have BH is equal to FH. Okay. So you got EH is equal to CH. EH is equal to CH. And you have BH is equal to FH by CPCT. Okay. Now, similarly, in triangle DGF and triangle AGE can be proved congruent, and you will get AG will be equal to GF and you will get EG will be equal to EG. Okay. If we, similarly, you will not prove these two triangles congruent again. Got it? So let this be our equation number 1. Now in triangle CDE, in this triangle CDE, complete triangle CDE, you have F and H are the midpoint of the sides CD and CE respectively. Therefore, FH is going to be parallel to BE and FH is equal to half BE. So this is how you get FH is equal to G. You get FH is equal to GE because half of D is nothing but GE. So you get FH is equal to GE. Similarly, you can prove that FG is equal to EH. And since the pair of opposite sides is parallel and equal, you get GEHF is a parallelogram. You get GEHF is a parallelogram. Moving to question number 8. In triangle ABC, you have D and E are the points on side AB such that AD is equal to DE is equal to EB. Through D and E, the lines are drawn parallel to BC. So you have DF is parallel to EG is parallel to BC. These three lines are parallel, which meet BC at points M and N, which meet BC at point M and N respectively. We have to prove that BM is equal to MN is equal to NC. Okay. So we'll be using equal intercept theorem here. So in triangle AEG, since D is the midpoint of AE and DF is parallel to EG, therefore by converse of midpoint theorem, you get F is the midpoint of AG. So you get AF is equal to GF. Let this be equation number 1. Now DF is parallel to EG is parallel to BC. So and you have DE is equal to BE. So therefore by equal intercept theorem you get FG is equal to GC. You get FG is equal to GC or GF is equal to GC. Got it? Now since AF is equal to FG and FG is equal to GC, you get AF is equal to FG is equal to GC. All these three are equal. Now, the intercepts, we have these three lines parallel. Which lines parallel we are talking of? AB, line AB is parallel to MF, is parallel to GN because by construction. And intercepts made by the transversal AC are equal. So, let us have one more line parallel over here at C. Let us draw a line parallel at C. Let us say line L is parallel over here. So we have GN is parallel to FN is parallel to AB is parallel to, let us say, line L. And you have AF is equal to GF is equal to GC. Therefore, by equal intercept theorem, we get BM is equal to MN is equal to MC. Got it? Question number 9 is very easy. In triangle ABC, you have M is the midpoint of AB and N is the midpoint of AC, and the line segment drawn parallel joining the midpoint is going to be parallel to BC and half of it. So we use the intercept theorem over here. So as M and N are midpoint, therefore by midpoint theorem you get MN is parallel to BC. MN is parallel to BC. Now let us draw a line L which is parallel to MN parallel BC, and the intercept made by transversal AB are equal. That is, you have AM is equal to BM. Therefore, you get AX is equal to DX. You get AX is equal to DX, and thus you can say that MN bisects AD at X. Bisects makes two equal parts of AD. The last question of this exercise, if the quadrilateral formed by joining the midpoints of the adjacent sides of a quadrilateral ABCD is a rectangle, show that the diagonals AC and BD of the bigger one quadrilateral, they intersect at right angle. So what is given to you? You are given quadrilateral ABCD where P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of DC and S is the midpoint of AD, and the quadrilateral form, that is PQRS, is a rectangle. We need to prove that the diagonals intersect at right angle. So they're intersecting at O. So we need to prove that AC and BD intersect at right angle. This angle we have to prove a right angle. So let's start with the proof by midpoint theorem. PQ parallel AC. So PQ parallel AC. So we are using the midpoint theorem for triangle ABC. In triangle ABC, line segment PQ. P is the midpoint of AB and Q is the midpoint of BC. So by midpoint theorem, you get PQ is parallel to AC. So since PQ is parallel to AC, we get angle AOD. This angle AOD is equal to angle PXO, corresponding angles. Let this be equation number 1. Again, we will have BD is parallel to RQ. BD is parallel to RQ. We consider the triangle DCB. So where R is the midpoint of DC and Q is the midpoint of CB. So by midpoint theorem, you get RQ is parallel to BD. Now, if RQ is parallel to BD, you get angle PXO. This angle PXO is equal to angle RQX, which is 90 degree. Since each angle of a rectangle is a right angle, so therefore this angle also has to be 90 degree. So you get this angle as 90 degree. And then from this equation, since we have AOD is equal to PXO and PXO is also equal to RQX, which is 90 degree. This is how you get AOD as right angle, which is 90 degree. And thus we can say that AC and BD intersect at right angle. Got it? So children, if you feel that this video has helped you, please see that you share with your friends and they also get help. And if you are new to the channel, please subscribe. Thank you for watching. Have a good day.